Hello and welcome to 1992 of the H series. We will continue today with Michael Stark's remarks on Wittgenstein Gödel, etc. Last time it was more of an introductory, not so much substance. That we were talking about the mechanization of mathematics that is impossible. Could be compared to a similar phrase, algorithmication of mathematics. That is almost the same thing. And also to be compared with algorithmatizing thinking, language, and so on. Gödel did not even Gödel did believe in some sort of blind formalism. It did not seem possible to him. So no ChatGTB according to Kurt Gödel. Wittgenstein, his vision was thinking is a thing in itself, has not really anything to do with algorithms. This equals very nicely Sir Roger Penrose's idea of uncomputability of thinking. It doesn't mean that thinking is random. Actually, just the contrary. Algorithmic thinking is random because it's just a haphazardous repetition of something that we've already done before, following a scheme. So there is much less sense to thinking than we think. Maybe thinking doesn't make much of a sense at all, as we put it into some sort of logical stance. Logic seems to be belonging to the aftermath, after the collapse of the wave function or the potentiality function. Then we have logic, then we have time and space, not before. But I will now continue at page 6. 6. Berto notes that Wittgenstein also denied the coherence of metamathematics. That is, the use by Gödel of a meta-theorem to prove his theorem, likely accounting for his notorious interpretation of Gödel's theorem as a paradox. As a paradox. And if we accept his argument, I think we are forced to deny the intelligibility of meta-languages, meta-theory, and meta-anything else. Meta. How can it be that such concepts, words, as metamathematics and incompleteness, accepted by millions, are just simple misunderstandings about how language works. How language works. Works. Isn't the proof in this pudding?
Yummy, yummy.
That's it. Pudding that, like so many revelatory philosophical notions, they will have no practical impact whatsoever.
Whatsoever.
Berto sums it up nicely. Within this framework, it is not possible that the very same sentence turns out to be expressible but undecidable in a formal system.
My system. Oh, my system. Yummy, yummy.
And demonstratively true under the aforementioned consistency. The aforementioned consistency.
Hypothesis.
Hypothesis. Oh dear. Hypothesis in a different system, the meta system. If, as Wittgenstein maintained, the proof establishes the very meaning of the proved sentence.
Proved.
Of the proved sentence.
Proof.
Then it is not possible for the same sentence, that is, for a sentence with the same meaning, to be undecidable in the formal system.
Formal system.
But decided in a different system, the meta system. Wittgenstein had to reject both the idea that a formal system can be syntactically incomplete and the Platonic consequence that no formal system proving only arithmetical truths can prove all arithmetical truths. If proofs establish the meaning of the arithmetical sentences, then there cannot be incomplete systems, just as there cannot be incomplete meanings.
Incomplete
Meanings. And further, inconsistent arithmetics, that is, non-classical arithmetics based on a paraconsistent logic are nowadays a reality. A reality. A reality. What is more important, the theoretical features of such theories match precisely with some of the aforementioned Wittgensteinian intuitions. Intuitions. Their inconsistency allows them also to escape from Gödel's first theorem and from Church's undecidability results. They are demonstrably complete and decidable. Undecidable.
Decidable, decidable, decidable. Decidable.
Decidable.
Decidable.
They therefore fulfill precisely Wittgenstein's request, according to which there cannot be mathematical problems that can be meaningfully formulated within the system, but which the rules of the system cannot decide. Cannot decide. Cannot decide.
Cannot decide.
Hence, the decidability of paraconsistent arithmetics harmonizes with an opinion Wittgenstein maintained throughout his philosophical career. Wittgenstein also demonstrated the fatal error in regarding mathematics or language or our behavior in general as a unitary, coherent, logical system. System, system, system. Systems unite, rather than as a motley of pieces assembled by the random processes of natural selection.
Motley of pieces. Motley of pieces. Pieces. Yum yum.
Pieces of something. Gödel shows us an unclarity in the concept of mathematics, which is indicated by the fact that mathematics is taken to be a system. And we can say, contra nearly everyone, that is all that Gödel and Chaitin show. Wittgenstein commented many times that truth in math means axioms or theorems derived from axioms. and false means that one made a mistake in using the definitions, and this is utterly different from empirical matters where one applies a test. Very important. A test. We need tests for those things.
This is utterly different from empirical matters when one applies a test.
Wittgenstein often noted that to be acceptable as mathematics in the usual sense, it must be usable in other proofs, and it must have real world applications.
Real.
But neither is the case with Gödel's incompleteness. Incompleteness.
Incompleteness. Incompleteness.
Ink. Completeness, no ink. Since it cannot be proved in a consistent system. Here, piano arithmetic. Piano. Let's play the piano.
Piano.
Da, 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 da. Arithmetic, but a much wider arena for Chaitin.
Arena.
It cannot be used in proofs, and unlike all the rest of PA, it cannot be used in the real world either. No, it cannot.
Oops.
As Rodich notes, Wittgenstein holds that a formal calculus is only a mathematical calculus, that is, a mathematical language game, if it has an extra systemic application in a system of contingent propositions.
Contingent.
For instance, in ordinary counting and measuring, or in physics. Another way to say this is that one needs a warrant.
Did I like?
To apply our normal use of words like proof,
Proof.
proposition,
Proposition.
true,
True.
incomplete, number, and mathematics to a result in the tangle of games created with number and plus and minus signs, etc. And with incompleteness, this warrant is lacking.
Tangle of games. Tangle of games. Tangle of games.
Rodich sums it up admirably. On Wittgenstein's account, there is no such thing as an incomplete mathematical calculus, because in mathematics everything is algorithm and syntax, and nothing is meaning, semantics.
Nothing is meaning, semantics, yummy, yummy.
Wittgenstein has much the same to say of Cantor's diagonalization, and set theory. Set theory.
Set theory.
Consideration of the diagonal procedure shows you that the concept of real number has much less analogy with the concept cardinal number than we, being misled by certain analogies, are inclined to believe, and many other comments.
Many other comments.
See Rodich and Floyd.
Real number has much less analogy with the concept of cardinal number.
Indeed. In any case, it would seem that the fact that Gödel's result has had zero impact on math should have alerted Hofstadter to its triviality and the strangeness of trying to make it a basis for anything. Anything. I suggest that it be regarded as another conceptual game that shows us the boundaries of our psychology.
Boundaries of our psychology.
Of course, all of math, physics, and human behavior can usefully be taken this way. By far the most famous remarks on Gödel are those by Douglas Hofstadter in his book Gödel, Escher, Bach. Bach, the eternal golden braid, which was subsequently discussed in his book I Am a Strange Loop. Regarding Gödel's famous theorems, in what sense can they be loops? What they are almost universally supposed to show is that a certain basic kinds of mathematical systems are incomplete in the sense that there are true theorems of the system whose truth, the unfortunate word mathematicians commonly substitute for validity, or falsity, invalidity, cannot be proven in the system. System. Though Hofstadter does not tell you these theorems are logically equivalent to Turing's incompleteness solution of the famous halting problem for computers performing some arbitrary calculation. Calculation!
Arbitrary.
Calculation, Kalle. Calculation. He spends a lot of time explaining Gödel's original proof, but fails to mention that others subsequently found vastly shorter and simpler proofs of incompleteness in math and proved many related concepts. Alla taftor och isho. Regarding the one he does briefly mention is that of the contemporary mathematician Gödel Chaitin, an originator with Kolmogorov and others of algorithmic information theory, who has shown that such incompleteness or randomness is much more extensive than long thought, but does not tell you that both Gödel and Turing's results are corollaries to Chaitin's theorem and an instance of algorithmic randomness. Algorithmic randomness. You should refer to Chaitin's more recent writings, such as the Omega number, as Hofstadter's only reference to Chaitin is 20 years old. Hofstadter takes this incompleteness and language game out of context. To mean that the system is self-referential or loopy and strange. It is not made clear why having theorems that seem to be true, that is valid in the system, but not provable in it, makes it a loop. Nor why this qualifies as strange, nor why this has any relationship to anything else. Hofstadter, in all his writings, follows the common trend and makes much of paradoxes. Much of paradoxes as he can. Paradoxes everywhere. as he can. Which he regards as self-references, recursions, or loops. But there are many inconsistencies in intentional psychology, math, language, perception, art, etc. And they have no effect as our psychology evolved to ignore them. Thus, paradoxes such as "this sentence is false" only tell us that this does not refer to itself, or if you prefer, that this is one of the infinitely many arrangements of words lacking a clear sense. Any symbolic system we have will always have areas of conflict, insoluble or counterintuitive problems, or unclear definitions. Hence, we have Gödel's theorems, the liar paradox, inconsistencies in set theory, prisoner's dilemmas, Schrödinger's dead life cat, Newcomb's problem. Oh, you were in contact with him actually. I emailed him.
Newcomb.
Yeah.
Kom för låt det här.
Anthropic principles, Bayesian statistics,
Yummy.
Professor Mustad, notes you cannot sound together, or colors you can't mix together. And rules that cannot be used in the same game. A set of sub-industries with decision theory, behavioral economics, game theory, philosophy, psychology, sociology, law, political science, etc. Even the foundations of physics and math. Has arisen which deals with the endless variations on real, for instance, quantum mechanics, or contrived, Newcomb's problem. Situations where our psychology evolved only to get food, find mates, and avoid becoming lunch.
Yum.
Give ambivalent results, or just breaks down. Breaks down, an excellent stopping point. 1992.
Yes. Breaks down. Is it not too dangerous to finish it break down?
Come again?
You're not superstitious, breaks down?
No, it's okay. It has a positive sense here. It's a sense of positivity here. It's a sense of positivity here. We need not be worried. At all. Let's go back to page 6. The last, yeah, exactly there. Perfect. It's about the meta system. If, as Wittgenstein maintained, the proof establishes the very meaning of the proved sentence, then it is not possible for the same sentence, that is, for a sentence with the same meaning, to be undecidable in a formal system, but decided in a different system, the meta system. Wittgenstein had to reject both the idea that a formal system can be syntactically incomplete and the Platonic consequence that no formal system proving only arithmetical truths can prove all arithmetical truths. So hold your tongue here. Meta language doesn't solve the problem, they bring it one level further up. So he's doing two things in one go here, and this is needed. It is needed of you to really look out here. This because it's becoming really difficult. He is attacking the Platonic as well as the idea that the Platonic is false at the same time. Second paragraph, page 7. Let's carry on. Wittgenstein also demonstrated the fatal error, the first one, in regarding mathematics or language or our behavior in general as a unitary, coherent logical system. It is not unitary, it's not coherent, and it's not a system. It is rather a motley of pieces assembled by random processes. And at the end of that, there is a quote from Rodich. We go down almost to the end of this paragraph, if you can, Kalle. As Rodich notes, as Rodich notes, Wittgenstein holds that a formal calculus is only a mathematical calculus if it has an extra systemic application in a system of contingent propositions. For instance, in ordinary counting and measuring or in physics. Let me dissect that. Almost need to put something on. No, I don't know. I will try anyway, just with words here. The extra systemic, it needs to reach out of the inside. Doing criterion stage setting we mentioned before. This comes in hand now to understand this. It needs to reach out. You have to do something. And the examples is counting or measuring in physics. Measuring or in physics. You do something with that, then you can know whether it's viable or not. Without that act, it doesn't have much semantic meaning. It doesn't have any meaning. The meaning comes from use. And he's then also claiming proof, proposition, true, incomplete, number, and mathematics is a result of a tangle of games created with numbers, plus, minus, signs, etc. And with incompleteness, this variant is lacking. So now it's really complicated, but all these things, they are doings in the world. That is what gives them meaning. Without a doing in the world, they have no meaning at all. And now comes the crux. This is really advanced. He turns that on Hofstadter. So Hofstadter is valid up for 99% of the population. I still hold on to be true to that. But now we're advancing into the Wittgensteinian Penrosian area. Everything becomes different. And all of a sudden, the loop that Hofstadter is talking about is not valid anymore. Why? Because it is in a meta language. It is in a language that is not casted in doings. So this is the complexity. So he both admires Gödel and puts him down at the same time. And so does the text. And to any purpose, I say Gödel still holds. But in this specific, for maybe a very few people, there is a specific point that's made. This tiny. It's like millimeter sharp. Nothing more than that. So if you go to page 9, you will hear a repetition of that. Hofstadter takes this incompleteness, a language game, out of context to mean that the system is self-referential or loopy or strange. It becomes that in this circumstance. But let me press one last time. Without Gödel, you will never come to the understanding of Wittgenstein. There's no possibility. You need to start there. And that still holds to 99% of the cases, no doubt. So it's a ladder-wise. There is no common truth, as Wittgenstein says it. A common truth is nonsensical because we all play different language games and we have different skills and we are differently advanced. So it doesn't hold generally. So this is a specific Wittgensteinian point, which is quite interesting because it parallels Penrose. This is one of the reasons why Penrose means that consciousness cannot be computational. Actually, even physics, in a certain way, cannot be computational. Kalle, please come in.
Let me go to the same sentence. So what is meant with Taylor games with numbers plus minus? I take it to mean that theory is entangled with life in one way. But I don't know if Starks agrees with this. He does agree with that because his sentence is very convoluted.
It's very complicated, the whole thing. He means, so to say, that a number is a sort of doing. This is, I think, counting, ordinary counting, which is mentioned in parentheses on the top, you can see there. Counting is something you do. 1, 2, 3, 4, 5, 6, and you can do it silently. 1, 2, 3, 4, 5, 6, and you can do it in your head. You do it. And another important pointer, which could be helpful, is that the plus and minus signs are written.
Yes, of course, they're written.
But that's very important. If they are done, this is a movement. We forget that we have typewriters and now we even have computers. So it's easier today to become Platonic as a mathematician because you don't notice that you actually write them. You just press a key.
How does plus and minus relate to incompleteness?
Come again?
How does plus and minus relate to incompleteness? How are plus and minus incomplete?
Where do you find that?
Here.
No, incompleteness, this variant is lacking, is referring to the whole sentence. There is no interwovenness with real things, doings. Incompleteness is,
But we need these doings, that is the point, of course.
yeah. Exactly. We need that for incompleteness, for instance. It doesn't have that word. It has other beneficiary things. But it doesn't have true or false.
In other words, when a mathematician writes, for instance, plus or minus, then this mathematician can be in the illusion that plus or minus exists only in the Platonic world, while the mathematician has forgotten that it has a relevance in the real world, that is in, let's say, the Celsius.
Yeah, exactly. Yeah, very good. It's a tough nut to crack, but
It's also incomplete in the sense that it is not, plus and minus are not truths in themselves, like in a, let's say,
in a higher realm or transcendentally.
They are not complete in the sense that it's only real on the paper, but it's that they are incomplete in the sense that they continue in the real world.
Yeah, we had a similar thing a couple of lectures ago with infinity.
Absolutely. And let me go to page 9 now to another thing here. This sentence is false. False. This sentence is false. No, it was not here. Let me comment on this. I would say that this affirmation I would not agree with this. Let me explain it. But I will first read it. Thus, paradoxes such as this sentence is false only tell us that this does not refer to itself, or if you prefer, that this is one of infinitely many arrangements of words lacking a clear space. And
clear sense.
Lacking clear sense. Let me show this by opening.
One more of those difficult sentences he writes. He's not very far from the Swedish police.
Let me see. It's a paper by Lin. I think it was this one about the paragraph with the bachelor. No, bachelor.
Bachelor, yeah.
Bachelor. Why is it not the right?
L.
There is.
O-R.
No, it's not the correct paper. Let me see the other paper.
I do remember it now. There was 2 rules, 3 rules. The first rule was that of ostensive definition. The second one was about.
Yes. So this is the paper of the impossibility. So we have. So first we have different rules. One is ostensive definition. This color is called red. It's a grammatical rule. The second type is a of grammatical rules. Unmarried called is explicit.
When you tell something, explicit formulation, you can say, an unmarried man is called a bachelor.
And then third is about rules. Another rule is just is in such a case, this is how one moves. Okay, let me now compare this with Stark's. This paradoxes such as this sentence is false only tell us that this does not refer to itself. So I would say that this sentence is false. This is actually a mix of 2 rules. It's both a grammatical rule and it's the third. It's a doing. It's a grammatical. It's a usage. It's about usage. So so something can be both self-referential, like this. This is like a Saussurean pointing, or Augustinian. You point at
Augustinian, yes, ostensive definition.
this is possible, of course. You learn by this. So this is so start this refuting this Augustinian pointing thing, but it's not false. So it's an internal loop, so to say. It refers to itself. But then there is also something that goes outside of it. It's about moves within the language game. So it's both an inside and outside thing. Let me show you. I will actually show. Let's say the number 8. We can think about the number 8 like an image. And this summarizes what we have been speaking. So we can on one side look at this as 2 circles.
Yeah, sure.
But that is, this morning we concluded in the paper, or this was my analysis of canon, that circle is a symbol for devil or Antichrist.
If you like.
Because you enter easily in thinking that nature is like that. Consists of 2 circles. But instead the real world is like, one way it's a loop, or it's a rather Möbius. So it's easy that this is more like a real 8. You see this 8. This is more like you see this one. This is the real 8. This is how nature works. So it's more like a Möbius strip. So that is how. So I would say that this is false. It's opposed internal and external.
Well, I think he says that actually. Or if you prefer that this is one of infinitely many arrangements of words lacking a clear sense. And with a clear sense, he means ambiguity. It has different senses.
Okay. Why not?
Any symbolic system we have will always have areas of conflict. And that's not a problem for him. Neither for me.
And there was something about cardinal numbers. There was this affirmation that the concept of real number has much less analogy with the concept of cardinal number. This was an affirmation by whom? Who said this? This was it Wittgenstein who says this? It's not clear who speaks here.
It's Wittgenstein.
Yes.
As much the same to say of Cantor's diagonalization.
Excuse me. Let me see cardinal numbers. We can a little bit.
I'm more than happy to take out piano and the diagonalization, but I need a whiteboard and some time to prepare that. I would say it's impossible to understand just by reading, because it's actually proof written, drawn.
So cardinal numbers are a problem. We should. What we could say is that what is a real number is like first, second, and third. They are more like they are more like real numbers, not cardinal numbers. So here we could agree. But let me end there.
Yeah, sure. Well, thank you very much, Kalle, for your insightful comments. It's a very difficult text. It's actually it's one of the hardest things in mathematics I read, and the piano diagonalization can only be shown on the whiteboard, and even then it took me years to understand it. But it's not important. You can still get the zest of the meaning without getting into the piano thing there. Piano. Thank you very much for listening in. Have a beautiful day, morning, or afternoon, wherever you are. Bye-bye for now.